Good morning, good afternoon, guys. I hope you all are having a good day so far. This assignment should be given to you somewhere about Wednesday or Thursday, April like 29th or 30th. This is actually going to be the last video that I make for you. You have you have two more sets of notes, but those are going to be I'm going to upload those from Pearson from my homegirl Elaine, the lady that we used to watch at the beginning of the year that I would joke around that I knew from high school, or I would joke around that I used to date her. I think some periods that I told her I knew her from high school. Or so I made a lot of jokes, but I don't have time to make all these last two videos. So the last two sets of notes you're going to see next week are going to be just recordings from Elaine and the old worksheets that we used to do. This one will be the last video that I'll make for you. Again, I just want to remind you guys how much I care about you. I'm sorry that I'm not there with you to the end of the year. If you need anything, most of you all should have either my email or my phone number. Don't forget that if you need something, please let me know, okay? I'm certainly missing you by now. This is already probably the second week that I've been gone. But I hope you can get through these. I hope your next few weeks go easy and you can get to the end of the year. And I will see you all at graduation. Okay. This is assignment number 15. It's further graphing objective 3. And what we're going to do here is we're going to find the minimum or the maximum value of quadratic equations. What you should be asking yourself is what is a minimum or a maximum? So what do those words mean? I kind of defined it in one of the videos previously, but now we're going to go into it in detail. We will find the minimum or maximum of quadratic functions, and you all will solve word problems and determine the minimum or maximum of quadratic functions. We're going to define and explore. Work with me. Example, if a projectile is fired straight upward from the ground with an initial speed of 96 feet per second, then its height h can be modeled by the equation below. Find the maximum height of the projectile. So here we see that word maximum, okay? So I'm going to tell you this, because we have to first look at this equation. We know it's a quadratic function because of that square there. So we know we're either going to get a parabola going like this, or we're going to have a parabola going like this, okay? Based on the equation, we now know that this a value is negative, so we're not going to have upward. We're going to have a downward facing. This negative a tells us that our parabola is going to be facing downward, okay? Now we need to read through the rest of the problem and kind of identify some key points. So projectile just means like a missile, a bullet, something that you shoot out of a gun or something. It's fired straight upward. So straight upward means it's going to go straight up from with an initial speed of 96 feet per second, and then its height can be modeled by the equation below. So basically, you're going to shoot something up into the air, it's going to come back down, and what we're trying to figure out is the maximum height, okay? So maximum is at the top of a parabola, and minimum is at the bottom of a parabola, and that's it. That's the definition of min and max. So let's take a look here. What we can do is that we know if we take our x and y coordinate plane and we take our 0, 0, and we have that projectile fired up, then it's going to come back down. It's going to make this upside down parabola. What we're trying to find out is what is this height? That's our h. So we know a couple things. And the reason I drew it this way is because we can say, okay, well, what do we know? We know that we can identify this would be necessarily called the vertex. So if we can find the coordinate points of the vertex, we'd be able to find this maximum height. And if we know this point, then we'll know h because it's just our y value. Does that make sense? So really what we're trying to find is, when it says find the maximum height, what we're really looking for is a vertex, okay? We have equations and we have ways to find that. We have a couple different ways. We can graph it, or we can rewrite our equation so it's such that we have it in the form of h or k. And let me check my notes and see how we did this in the notes. So you know what I'm going to do? Instead of rewriting all this equation and trying to figure out what's what, you know what I'm going to do? Since I'm looking for a vertex, I'm going to use the vertex formula. And it said, remember, we need an x and a y for the vertex. It says that if I take the negative b and divide by 2a, that'll give me my x, and my y is the function evaluated at the answer I got for negative b divided by 2a. Okay, I left a little bit more space, so let's see what that looks like. Remember, our a value right here, negative 16. Our b value, 96. So what we're going to do first to find the x of our vertex, negative b divided by 2a, remember, negative 96 divided by 2 times 16, negative 16. If you do that little baby math, you can use a calculator or your phone, you're going to wind up getting the number 3. Okay? So we know our x value is number 3. Our x value is 3. So we know we're going to be at 1, 2, or I'm sorry, I kind of drew this ugly, but 1, 2, 3. Now we just need to find out our y. And our y is this function evaluated at 3. So here's how we're going to write for our y. It's the function h, but instead of t, I'm going to put 0. No, I'm going to put the number 3. And everywhere there's a t, I'm going to replace it with that 3. Okay? So instead of t squared, I'm going to put 3 squared. And instead of t, I'm going to write 3. Negative 16, that becomes negative 16 times 3 is 9. Plus 96 times 3. I'm going to be honest, I got to use a calculator. So let me get my little phone calculator. And let's do negative 16 times 9. That's negative 144. 96 times 3, that's 288. And our final answer is equal to 288 minus 144 and equals 144. Okay, so our y, remember we're solving for y, equals 144. So these are my two numbers. My answer for x is 3, my answer for y is 144. So the vertex is at 3, 144. So that means if the vertex is at 3, and this is like, so this would be like, oh my god, there'd be so many lines here. Yeah, 144. That means our h equals 144 feet. Okay. So it seems like a complicated question, but really all we needed to understand is maximum means the vertex. And we know we have a formula for vertex. We can just substitute in these numbers, the negative 16 and the 96, to this equation. We get the answer 3. Then we take that answer, substitute it into the equation here, evaluate the function at the 3 to get the 144. So really we're just solving for x and y. Ooh, no, what did I do? Let me close this up. Okay. Let's take a look at another example. I think I just gave you guys one practice. So it's a little bit different. The length and width of a rectangle must have a sum of 22. Okay. So we'll draw a little sketch. The length and width of a rectangle must have a sum of 22. So we don't know what the length and the width are, but we know that if we add them, sum means add, they're going to equal 22. Now we need to find the dimension of the rectangle that will have the maximum area. Okay. So the hint, let x and 22 minus x be the length and the width. So this came from, let's say we called Lx. Okay. So then we would get x plus w equals 22. And then we would get x equals 22, or subtract x, that's where this came from. And that's where this came from. Okay. So we kind of set up the equation for you. What we need to do is distribute this and distribute this. 22x minus x squared. We're going to rewrite this. So guess what? We know that our a value is negative, so we're going to have some kind of parabola with the maximum. This is our b value. We're going to solve and find the vertex. If we can figure out what our x is, this will give us the max value. Okay. X is going to have the maximum value at this. So what? X equals 1. And remember, y is the function evaluated at 1. So that's 1 times 22 minus 1. That equals 1 times 21 equals 21. So our vertex here is going to be at 1, 21. So our maximum area is going to be when x equals 1 and that y is 21. Okay. And that's it. You guys just need to use this little vertex formula and plug that in and you'll figure it out. So follow the same steps and try number 2 on your own. And like I said, this is the last video that I'm going to make for you guys. I hope you all are doing well. I hope to see you all soon. Hope you all have a good week, okay? The next 2 videos are going to be my home girly lane.